At the end of last time, I left you with some code. I said, look for the patterns in the code. Where could we make this code simpler, possibly smoother, or easier to write and maintain? Hopefully you had to think about it, but let's have a look at the code and see if we can spot any bits which are repeated. So the most obvious repeat to me is this delay 1000 line. One of the nice things about this software is when you highlight a line like that, if the line is identical anywhere else, other lines get highlighted as well. So you can see here we're using exactly the same line. Now, as it is, it's a very short program. That's not a problem, really. But what we might want to do is instead we might want to vary that length of that delay. We might want to change its length. So what we're going to do is we're going to create what's called a variable. Now, variables are little bits of memory where you can store a value temporarily. These macros, these defines at the top, those are stored permanently and they can't be changed by the Arduino program itself. They are only visible to the IDE, the software, as it's programmed. A variable, on the other hand, can actually be stored in the Arduino's memory, recalled, modified, changed, updated. So what we're going to do is inside our setup, we're going to create a variable. Now, variables can be of a number of different types. The first type is an integer, int. So ints store numbers. The next type, which we might use a bit, is called a boolean or a bool. These store values of true or false. Technically 1 or 0. The other one that we might use at the moment is a character or a char. These store letters or numbers as text. So those are the first 3 types of variable we're going to use. Now, if we want to do something about this delay and bring that into a variable, which one of those types of variable are we going to want? Well, it's obviously a number. It's actually an integer number we want to store. So let's delete all of those. And instead, let's have an define our variable. So the way you define a variable is you tell it what type it is. It's an int. And then you give it a name. Now it's a time. There are some words which are protected, but we'll just use int t. And we're going to give it an initial value. Int t equals 1000. Semicolon. We can now go down into our loop and we can make this 1000 t. If we hover over it, it doesn't spring up as a macro anymore. It's now actually a variable. So that's fine, that works. If we change this value here to say 500, the actual software will change. So let's just check it works, verify. T was not declared in this scope. That's interesting. And it's interesting because the way variables work, we've declared it here inside our setup. You would think that would make sense. But what that does is it traps that t inside setup. It makes it what's called a local variable. Loop can't see it because it's inside. What we actually need to do is we need to grab the whole thing, Control X, and we need to bring it up here into the global variables. And what we'll sometimes do is we might go hash / for a comment globals. That just reminds us what follows the globals. global variables, the variables that can be accessed anywhere. T should now be available to loop, so if we verify it again, the error goes away. Let's actually push that to the Arduino and see what happens. If we've done it right, we should notice no change. So let's go and have a look at the Arduino and uploading. Carries on exactly as before. What I'm going to do in the background is I'll change that value of T to 500 and upload it again. And what should happen? The flashing is a lot faster. If I change it to 5,000 and upload it, then suddenly our gaps, our waiting times become a lot bigger. So that's the first thing that we can do to our code. We have written there a code involving a variable. If we now go back to our code again, and you can see here is our T equals 5,000. Actually, I'm going to put that back to being 500 now before I forget, otherwise it'll be too slow later. What we're going to do is look at the rest of this code. This is actually very similar to itself. We've got one LED being written as high, one LED being written as low, and a delay. So I wonder if, and these two are always opposites of each other. So let's see if we can write ourselves a function that can capture that. So the way we write a function is we've got to tell it what type of variable is coming back. So it could be an integer, it could be a character, it could be a Boolean, or, and this is one that's a bit weird if you're not used to it, if the function's not going to send any data back to the program, we say void. And a lot of our functions will not return anything. This one is not going to return any value. It's going to make changes to the system, but not return any value for the computer to work on. So it's void. We then need to give it a name. And let's just call this one set LED. So we're going to call our function set LED, and it needs to have a variable. Now, what we're going to do is we're just going to give it a name here. And let's set it as a Boolean. And let's call it I, just for the sake of it. And we're going to then use a curly brace. You'll notice when you start using brackets in this IDE, if you put the opening bracket in, it will give you the matching closing bracket. That's helpful and will save you a lot of pain later. So I'm going to put now a return in and scroll down a little bit. So anything we write now between this curly brace and this curly brace is part of the function set LED. So let's bring in all this code. So if we now call the function set LED and we send it true or false, it will run this program, which isn't very helpful because it's always going to set the red on, it's always going to set green off. That's all it's going to do. But if you remember when we talked about this, high is true, is on or off, can also be called true or false. This is a Boolean, true or false. So what we can do is we can change this high to I. So whatever value is passed through the function here will go into here. we want the opposite here. So what we really want is not I. Now, not I, that looks logical, but if I press verify, it's going to say not is not declared. In Arduino and C++ generally, if we want the opposite of a Boolean, we use the exclamation mark. So exclamation mark equals not. So if this is true, then this is not true, and not true is false. If we verify that, there's no error. So now we have the ability to set the red LED on by calling set LED true. And if we want it to be off and the green one to be on, we can set LED false. We have the delay in here. So now we can take this whole code here and delete it. And if we send this to the Arduino right now, and we're to have a look at the Arduino, the program's gone out to it, but absolutely nothing is happening. There's nothing wrong with the program because it's compiled. It's just we haven't actually called this function. So let's go into here and we'll go set LED true. That should make the red LED go on. Set LED false. That should make the green LED go on. If we hit verify, ooh, it doesn't like true and it doesn't like false. That's because in C, these have got to be lowercase. I always forget that. True is lowercase true, false is lowercase false. Notice how they've gone green. It now knows what they are. So if we hit verify, no problems, upload it. And if we have a look at our Arduino, it's back to exactly as it was. Now, it may not look like we've saved a lot of typing here. We've reduced our main loop from 6 lines of code to 2. But to do it, we've had to add this extra function with 3 lines of code in it. So we've saved 1 line of code overall. That's all. And you could argue with the function being created, we've not actually saved any lines of code. However, you can probably see how you could scale this up to having 20 LEDs or 30 LEDs. And in our next video, what we'll do is we'll set up a different circuit, and we will, instead of using true and false, we'll start passing a character and see if we can change the state of our LEDs by passing a character in. Perhaps we're passing R and G for red and green, and then you might be able to see how we can expand this further. But we'll save that for next time. So for the now, what we'll do is I'll say, have a play, see if you can get that to work, and we'll talk further next time.